Hi, hello everyone. This is Nepalidi sir from ANR Academy. Let us discuss today the problems based on locus topic. Particularly, the questions are of the form PA plus PB equal to constant and modulus PA minus PB equal to constant in a short way. Let us discuss the concept first and then we go for how to solve the problems in a short method. See here, if A comma B are two fixed points and P be any moving point such that there are three conditions. First one, PA plus PB equal to constant and that constant equal to AB. Second one, PA plus PB equal to constant and that constant is more than AB. Third one, PA plus PB equal to constant and that constant less than AB. First you have to choose two fixed points A comma B. Suppose that I am going to select two fixed points capital A and capital B here. This is A and this is B. Now you have to select a moving point P. It satisfies this condition. PA plus PB, that should be equal to AB. Suppose that if I select a point P here, then observe, suppose if it is P, then what happens? The distance from P to A and P to B, if you add these two, PA distance and PB distance, if you add up, then what we get? AB. Yes, sum of these two become the length AB here, so that this point is suitable for this condition. In the same way, you may select so many points. Here I am going to select another point P. Now from this point to A and from this P to B, these are the distances P and PB. Add up these two, sum of these two become again AB distance. So this is the point also satisfying the geometrical condition PA plus PB equal to constant and that constant equal to AB. Such points on the line segment itself. If you select a point here, here and here, these are the points only satisfying the condition PA plus PB equal to constant, which is equal to AB. So that joining all these points, we get a line segment. This is the locus of given condition. Next, second one, PA plus PB equal to constant and that constant should be more than AB is there. First I am going to select two fixed points A and B and then go for moving point P. Suppose that here there is a point A and here another point, it is B. Now let us choose the point P which satisfies this condition, the distance of P and PB whose sum should be greater than AB. I am going to select moving point, suppose P here. Then what happens? Observe, this is the distance PA and this is the distance PB. And this distance PA plus PB, sum of these two always greater than the distance between A and B. This is true in this case. Next, in the same manner, if I select the point P here, P to A and P to B, if you join, sum of these two distances always greater than the distance from A to B. Such a way that I am going to select another point P here in the downward direction and here another point, and there exist so many points which satisfies the condition, and joining all the points of P, then you will get elliptical shape figure. This is locus of given condition. So in this case, when PA plus PB is more than AB, here the locus is ellipse, remember. And you can easily recognize these two conditions. Already in high school sections, the students studied that the condition for collinearity, when the points are collinear, in the first case, suppose there are 3 points which are collinear, A, B, C. Then you can write the condition AB plus BC equal to AC. AB plus BC equal to AC. This is the condition for collinearity. Right? The same you have here. There are 3 points, capital A, capital B and P. Like AB plus BC equal to AC, you have here PA plus PB equal to AB. So that the condition satisfied by the points which are lying on the same line segment, remember. So that here the locus representing a line segment. Next, this one also you can easily remember. In high school section, the students studied that sum of two sides always greater than in any triangle. This is the property of triangle. Sum of two sides always greater than the third side. Suppose this is the triangle A, B, C. Sum of first two sides AC plus CB, that is always greater than the third side AB. So here I can write AC plus CB, which is greater than AB. When you have 3 points, this is the condition, this is the property of triangle. Like that you have the same PA plus PB is more than AB. So whenever the 3 points are non-collinear, then only it is possible, so that the point P is taken outside the line segment AB. That is, A, P, B are non-collinear. In that case, only this condition is possible. And here the condition PA plus PB equal to constant. So with constant distance, you have to select another point P. If you add up PA and PB, the distance should be particularly constant K. This is the distance K and this is also the distance K. If you select this one, also sum of these two again K, and if you choose the point here, PA plus PB again K. So that in such a way that there are so many points exist in the plane, and joining all these points we get an ellipse, that is the locus. And here let us observe the third condition. Here the same, but you have the inequality change in this. PA plus PB less than AB. Again PAB, there are 3 points. Suppose that they are vertices of a triangle. Is it possible sum of two sides less than the third side? It is not possible. So that it is impossible case, and hence locus not defined, or you can say that empty set. Right? So this is about the concept of PA plus PB. Let us discuss a problem based on it in a short method. See this question. Find the equation of locus of P if the sum of those distances from 0, 2 and 0, minus 2 is given as 6 units. See here, sum of the distances from 0, 2 to the locus point P and from the point 0, minus 2 to the point P, that is given as 6 units. First assume that locus point P, that is x, y, and assume that coordinates of A 0, 2 and coordinates of B 0, minus 2, and also assume that geometrical condition PA plus PB, which is equal to 6. Given data written here, Px, y, A 0, 2, B 0, minus 2 and PA plus PB equal to L. Sorry, PA plus PB equal to 6. I am going to use a short technique called as L plus M method. In 8th standard, you studied the identity a square minus b square equal to a minus b into a plus b. Using that formula, I am going to solve this question. What I am saying, in 8th standard you studied that L square minus M square, nothing but L minus M into L plus M. With the help of this, I am going to solve this question. Let us suppose PA, that is equal to L. Assume that this is L. And PB, assume that as M. L plus M given, L plus M equal to 6. First I am going to write here the value of L square. Next I am going to write M square. L square nothing but PA square. P to A distance is L. So PA square. Next M, P to B distance, that is M square means PB square. I am going to write PA square with the help of distance formula. X minus 0 whole square plus Y minus 2 whole square. Nothing but X square plus Y minus 2 whole square it is. Next PB square. Using P and B, with the help of distance formula, what we get? PB square, X square plus Y plus 2 whole square it is. Now subtract these two. Just now we discussed the short technique. It is by L square minus M square equal to L minus M into L plus M. On subtraction, left hand side, what we get? L square minus M square. That can be written as L minus M into L plus M, remember. And here on subtraction, here it is of minus sign, also minus sign. These two terms gets cancelled. Y minus 2 whole square minus of Y plus 2 whole square. It looks like A minus B whole square minus A plus B whole square, and the result is minus 4AB. So that here minus 4 A into B, nothing but 2 into Y we get. And you have L plus M here, the value equal to 6. So I can write 6 times L minus M. The value of L plus M replaced by 6. And 4 to the here, it is of 8 Y. On simplification, it is 3 times of L minus M equal to minus 4Y. Clearly you have 3 times L minus 3 times M, that is equal to minus 4Y. And you have L plus M 6. If you multiply with 3, this one, 3L plus 3M, that gives the result 18. Now adding these two, 3M gets cancelled. What is 3L plus 3L? That is 6 times of L equal to sum of these two, 18 minus 4 times of Y. Minimizing this, 3 times of L equal to 9 minus 2Y. Now apply square on both the sides. On squaring, 9L square equal to 81 plus 4Y square minus 36Y. What is the value of L square? Here you have 9 times of, on simplification you get the result, left hand side 9 times of L square, that is 9 times of L square value, X square plus Y square plus 4 minus 4Y, and in the right part you have 81 4Y square, next 36Y, it is equal to 0. Therefore 9 times of X square, 9 times of Y square plus 36 minus 36Y minus 81 minus 4y square plus 36y, it is equal to 0. Minus 36y plus 36y gets cancelled, and 9x square minus 4y square next equal to 81 minus 36, that is 45. Here it is of 5y square, right? Dividing with 45 each and every term, we get the final answer, that is x square by 5 minus y square by 9, it is equal to 1. This is of plus 5 square, right? 9y square minus 4y square value, it is plus 5y square. So that it is of the form x square by a square plus y square by b square equal to 1. It is an ellipse, remember. This is about the first case. Let us move to the next one. A comma b are two fixed points, p be any moving point such that mod pa minus pb equal to constant and that constant equal to ab. Second condition, pa minus pb constant and that is less than ab. Third one, modulus pa minus pb equal to constant, that is more than ab. See here, if I select two fixed points a and b on the plane, if it is a and this is b. Now you have to select a moving point p on the plane which satisfies this condition, pa minus pb should be ab. Yes, I am going to select the point P outside the line segment and that should be collinear, remember. If I select the point P here, this is the distance from P to A and from which you have to remove PB distance. Up to PB you have to remove. After removing this is the portion you got, that is clearly equal to AB. So the points which are collinear and right side of B, they satisfies the above condition. These are moving points. In this direction there exists so many points satisfying the above condition. In the same way, if you select left hand side a point P here, this is the distance from P to B and from which I am going to remove PA part. Mod PA minus PB is nothing but you may remove PA from PB or PB from PA. So that from PB if I remove PA up to A, if you remove then what we get? AB. So the points which are collinear with AB and left side of A also satisfying the same condition, and hence such points I am going to draw this one, this one, this one. So joining all these we get left hand side and right hand side, two rays, two opposite pair of rays exist in this case. And remember that the points are collinear. I am going to write locus, pair of opposite rays. This is the locus path. Next, second condition, modulus PA minus PB equal to constant and that constant less than AB you have. Suppose that there is a point A here and another point B. Now let us select the points, moving points P, which satisfies the condition their difference should be less than AB. If I select a point, non-collinear point here, what happens, observe. If I remove one of them from these two, suppose here PB is greater, so that I am going to remove PA. From PB, if I remove PA, P to A the distance you have in this way. So the same distance if I remove up to here, if I remove this portion, then you will get this part. This is clearly less than AB. After removing the same length PA from PB, then you will get this smaller portion. This smaller portion is always less compared to AB. So this is one suitable point. In the same way, I can select a point P here, and here, and here, and here, 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 and here. By joining all these points, we get a path. The path is known as hyperbola in this case. The locus of the path of points satisfying the O condition is hyperbola. Next, modulus PA minus PB more than AB. If you remove PB from PA, then you will get smaller portion but not greater than AB. It is impossible. So that here I am going to write, in this case is not possible. Therefore, locus is empty set. Let us discuss a problem based on it. See this. Find the locus of P if A 4, 0, B minus 4, 0, and difference between PA, PB, that is given as 4. Let Px, y be any locus point. A coordinates 4, 0, and another point B with coordinates minus 4, 0, and here the condition also given mod PA minus PB, it is 4. See, again I am going to use the same method, that is called now L minus M method. In 8th standard in polynomials topic, you studied that L square minus M square written as L minus M into L plus M. This I am going to use now. Assume that this is some L and this is M. First I am going to write the value of L square and then M square, and then difference of this. PA is L, so L square first I am writing. PB is M, PB square, M square. Now L square is nothing but square of the distance from P to A. That is clearly x minus 4 whole square plus y square it is. Next, M square, that is x plus 4 whole square plus y square. On subtraction, L square minus M square equal to A minus B whole square minus A plus B whole square. You know that the value is minus 4AB, so that here minus 4A into B, that is 4x. It can be written as L minus M into L plus M, that is equal to minus 4 of 4x. You know that the value of L minus M, 4. L minus M clearly 4. They are equal. So 4 and L minus M gets cancelled. You have the value of L plus M minus 4x, and you know that L minus M, that is equal to 4. On addition, what we get? MM gets cancelled. Adding them, we get 2 times of L, which is equal to 4 minus 4x. Therefore, L written as 2 minus 2x. Apply square on both the sides by taking 2 common. 2 into 1 minus x whole square. Right? What is L square? L square, here you have x minus 4 whole square plus y square equal to 4 times of, this is x square plus 1 minus 2x. On expansion, it becomes x square plus 16 minus 8x plus y square minus 4x square minus 4 plus 8x, that should be 0 here, plus 8x minus 8x gets cancelled. X square minus 4y square, x square minus 4x square, that is minus 3 times of x square. Next y square plus 12 equal to 0, and you can rewrite this equation as here it is of y square, okay, minus 3x square plus y square plus 12 equal to 0, okay. 4, yes, it can be written as 3x square minus y square equal to 12. On dividing each and every term with 12, we get 4 minus y square divided by 12 equal to 1. It looks like x square by a square minus y square by b square equal to 1. So it indicates hyperbola, remember. So locus of the point satisfying the above condition is a hyperbola. So this is the way of doing problems which are of the form PA plus PB equal to constant and PA minus PB equal to constant. On practicing, you will get very simple and very smart solution. Compared to this, you will get very smaller size solution on practicing this model. Thank you so much, and let us discuss the next topic in the next session.